Alright, so we're going to go through how to figure out molecular shapes here in a simplified sort of way. And I gave you the formula for homework, KRF4. Is that correct?
Correct.
Alright, so I'm trying to find my periodic table. I know it's here. It is. Here it is. Okay. Alright, please give me your complete attention, even though you think you've got it right. Okay, you don't need to pay attention anyway. Be quiet, not distract other people. Thank you. Okay, so here's krypton. Alright, now that if it's right here, it means that I've got, in this fourth row of the periodic table, I've got 2 electrons. This would represent the electrons in the valence level for krypton over here. 2 electrons in the S sublevel. All these electrons are 1 level down. That's in a D sublevel, so you have to drop back 1 level when you put those in. And 6 electrons in the P sublevel in that 4th primary level. So that means there are 8, 2 plus 6, 8 valence electrons for krypton. Okay, so krypton, we're going to put 1, 2, 3, 4, and the way I've taught you to do this is 1 dot on each of the 4 sides, and go back and pair them up if you need to. So 4, 5, 6, 7, 8 electrons. And fluorine, using that same system, it's right here in the 2nd row. It's got 2 S electrons in the valence level and 5 P electrons in the valence level for a total of 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay, and I need 4 of them. So I'll put in the fluorine here. And let's see, how about a fluorine here? And then a fluorine here. Alright. So, the guideline I gave you when we have to break up lone pairs. You only do it when you have to. Try not to break up any lone pairs, but if you have to, you break up the minimum number of lone pairs possible. So if I'm going to take an electron from, say, this pair right here on this side of krypton to share there, then I'm going to also take this one. So I'm breaking up at the minimum number of electron pairs. Okay? So we're making a sharing arrangement here. I'm going to do the same thing with this pair here. All right? Oh, I'm sorry. Oh, wrong. Good. All right, there we go. All right. I don't know why. That's how you don't do it. That's right. That's the do not do this. Okay. Made a mistake. All right. There we go. More or less. I know it. And I'm just more human than most. All right. So now to get the Lewis dot formula then, we're going to squeeze the electrons we're sharing in between the element symbols. So in this case, I'm going to need 6 pairs of electrons around krypton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 6 pairs. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On 4 of those, I want to have fluorines. Put a fluorine here, fluorine here, fluorine here, and a fluorine here. Nothing special about where I put them. I just decided to put them there. And I need to put the electron dots on those that are remaining, the lone pairs. And that would be a Lewis dot formula. So we're starting out with a sharing arrangement here. Actually, we started out with an electron dot formula, and then when we circled electrons to show the sharing, then we call it the sharing arrangement. And this is called the Lewis dot formula. That's what I call it anyway, just to differentiate between the two. And the Lewis formula, we're going to replace only shared pairs with lines. So here's a krypton, and I've got 2 lone pairs on the krypton, and I've got 1, 2, 3, 4 shared pairs. They're shared between krypton and fluorine. 1, 2, 3, 4, and put the fluorines on here. Okay? And so that's a Lewis formula. All right, going back to the Lewis dot formula then, I want to count the sets of electrons around the central atom. I want to count the sets of electrons around the central atom. You are not required to circle these. I'm just going to circle these to help you see where the sets are. Okay? So sets can be one of two things. One of the two things they can be is a lone pair. Well, I've got two of those around this central atom, so there are two sets. The other thing a set can be is the combination of all the electrons shared between two atoms. Well, I've got four of those sets. These are the two electrons, only two. They're shared between this krypton and fluorine and so forth. Okay, all these are shared. That's the total number of electrons shared between this fluorine, that krypton, this fluorine, that krypton, this fluorine, that krypton, and so forth. Okay, so I've got a total of 6 sets. All right, once you identify the number of sets, then you can identify what molecular shape you're going to choose for the electron pair shape. And the only shape that has 6 arms around it is an octahedral. So we're going to put our krypton in the middle here, okay? And an octahedral is going to have an arm going straight up and straight down. Those are our polar positions. And then if you think about the center here being the equator, if you think about this as then the center of the Earth, and this is the Earth here, this is North Pole, South Pole, and around that, okay, that equator, then we've got these other positions. So I've got one of the positions coming out toward you, okay? And one going back behind over here, and all these around all these are going to be 9 degrees apart. Okay, so all right. Now you can leave them as empty like that, empty triangles. That's fine, or you can darken them in if you prefer. Okay, in textbooks you'll see them darkened in, but most of the time, chemists when they're just drawing it out, they won't darken it in because it takes up a little too much time. All right, now. Remember, lone pairs take up extra space. Remember that yesterday? Lone pairs take up extra space. So it doesn't really matter where you put the lone pairs, but wherever you put the first one, the second one has to be on the opposite side. Okay? You can put lone pairs on the equator if you want to, but if you do, if I put it here, I've got to put it on the opposite side over here. But right now we're just going to go with just the electron pairs. This is our electron pair shape. Okay. All right, so that's our electron pair shape, and this is called an octahedral. And this is an electron pair shape. And then we're going to redraw the exact same drawing with the electron dots and everything. We're going to look up here at our Lewis dot formula and determine how many of the sets of electrons are shared. And then I'm going to replace the electron dots on this drawing with the chemical symbol here, the elemental symbol, for just those sets that are shared. Remember, we want to keep the lone pairs on opposite sides. You can have it here and here, or you can have it here and here, or you can have them in the two polar positions. It doesn't really matter. To me, it's a little bit easier to see the result if I put the fluorines on the equatorial positions. Okay? Does that make sense? And our lone pairs I'll keep in the polar positions. Nothing special about that. It's just easier to kind of figure out what's going on. But this is an octahedral still. And we're going to call this a modified electron pair shape. Okay? All right, we're about there. One more step. Since I have both atoms and electron pairs on the outside of these arms, then I need to do one more step here. If we had gotten here and there weren't any electron pairs on here, we'd be done. That'd be the molecular shape. We've got to get rid of the electron pairs to get the molecular shape. So we're going to put the same drawing again. put down the same drawing, and with the lone pairs, so I can keep the spacing right. This is probably between this step and this step, or between this step and this step, is where most students get it wrong on a test, because they want to take shortcuts, and you're just not ready to take shortcuts, okay? All right, remember you're Kim baby still, right? All right. So we're going to get rid of our lone pairs, and that's from that. I hope you're going to be able to see that this looks like just a flat plane, okay? Just a square laid down kind of flat. Does that make sense to everybody? That's what that. If you join the corners, that's what you get. You got krypton in the middle, and the fluorines make the four corners. Because when we're looking at molecular shapes, we're looking at the angles the atoms make and not so much the electron pairs. Okay, what matters in the long term is how we build these larger and larger molecules, and this is the beginning of that. So with the molecular shape, we ignore the electron pairs. Now we can't ignore them completely because they take up space. If it weren't for accounting for the space taken up by these lone pairs, then we would assume this would be a tetrahedral, but it's not because of those lone pairs. Okay, so now this then is square planar. Okay, it's a square, it's on a plane. I don't know why they call it square planar, because a square is a plane, but that's what they call it. So apparently whoever dreamed up these names was not a geometry teacher. And this is a molecular shape. Okay? Got it? Questions? Think you got all the molecular shape thing down? Do we need to practice anymore? Don't see anybody saying yes. I don't see heads going up and down or side to side. You want to practice some more? Okay. Alrighty then.